In this video, I am going to discuss BCom method. The other name of BCom method is Charnes method or method of penalty. The problem is minimize z is equal to 3x1 plus x2. Subject to the conditions 4x1 plus x2 is equal to 4, 5x1 plus 3x2 greater than or equal to 7, 3x1 plus 2x2 less than or equal to 6, x1 comma x2 greater than or equal to 0. In the first condition, you have equal symbol. So, you have to add the artificial variable. The second condition is greater than or equal to symbol. So, here you have to introduce surplus variable and artificial variable. The third condition is less than or equal to symbol. So, you have to add the slack variable. Let me write. The first condition is equal form. So, you have to add the artificial variable a1, that is 4x1 plus x2 plus a1 is equal to 4. The second condition is greater than or equal to type. So, you have to subtract the surplus variable and add the artificial variable. Add the artificial variable a2, that is 5x1 plus 3x2 minus s1 plus a2. This is equal to 7. Whenever you have to introduce surplus variable, you have to introduce artificial variable also. Now the third condition is less than or equal to type. So you have to add the slack variable. Add the slack variable s2, that is 3x1 plus 2x2 plus s2 is equal to 6. Now we have to write the standard form. The objective function is minimize z is equal to 3x1 plus x2. We have to convert this into equivalent maximization problem, that is maximize z is equal to minus minimize z. Always you convert the minimization problem into maximization problem. Then it will be easy for you to calculate. Maximize z is equal to minus 3x1 minus x2 plus, here we are introducing the surplus variable s1, slack variable s2, artificial variable a1 and a2. For slack and surplus variable, the cost is 0. 0 s1 plus 0 s2. And for the artificial variable, the cost is minus m for maximization problem. So, minus m a1 minus m a2. Subject to 4x1 plus x2, subject to 4x1 plus x2 plus a1 is equal to 4, 5x1 plus 3x2 minus s1 plus a2 is equal to 7, 3x1 plus 2x2 plus s2 is equal to 6. Finally, you have to write the non-negativity constraint, that is x1 comma x2 comma s1 comma s2 comma a1 comma a2 greater than or equal to 0. That is, the variables are always positive. Step 2 is find the optimum value using simplex table. The first one is B, the right hand side values. Here you have to write basic variables. The next one is cost you have to write, and here this is CJ. The first one is B, right hand side constants, then basic variable, the newly introduced variable you have to write here, then the cost of that particular variable, and here CJ is nothing but the coefficient of the objective function. Now let me write all the variables which we used in the given problem. x1, x2, s1, s2, a1, a2. The coefficient of these variables in the objective function is -3, -1, 0, 0, and for artificial variable the coefficient is -m. That is why this method is called Big M method. Now we have to write the right hand side values. The values are 4, 7, 6. The basic variables are, first condition we introduced artificial variable a1, second condition we introduced artificial variable a2, third condition we introduced the slack variable s2. Now we have to write the cost for those variables. For the first condition, the cost is -m, second one -m, and for the slack variable 0. Now you have to write the coefficient for the given conditions, that is 4, 1, 0, 0, 1, 0. Second condition 5, 3, -1, 0, 0, 1. Third condition is 3, 2, 0, 1, 0, 0. These are the coefficient of the given condition. Now we have to find Zj value. For finding Zj value, you have to use the formula Zj is equal to summation of Cb into jth column of the matrix. That is -m into 4 plus -m into 5 plus 0 into 3. If you multiply and add, you will get -9m. Now second column, -m into 1 plus -m into 3 plus 0 into 2. The value is -4m. The next one is -m into 0 plus -m into -1 plus 0 into 0. So the value is m. The next column is -m into 0 plus -m into 0 plus 0 into 1. So the value is 0. The next column -m into 1 plus -m into 0 plus 0 into 0. The value is -m. The last column -m into 0 plus -m into 1 plus 0 into 0. The value is -m again. Next we have to find Zj minus Cj. Zj is here, Cj is at the top. You have to subtract these two values. That is -9m minus of -3. You will get -9m plus 3. The second one is -4m minus of -1. You will get -4m plus 1. Then m minus 0. M. 0 minus 0, 0. Then minus m minus of -m. That is 0. Minus m minus of -m. That is 0 again. Zj minus Cj value is over. Now we have to check all Zj minus Cj values are positive and 0. Here some values are negative. In bigger method, you have to concentrate on the coefficient of m mainly. So here the most negative is minus 9m plus 3. So the corresponding variable enter into the next table. The most negative value is minus m plus 3. So the corresponding variable x1 enter into the next table. We have to find the outgoing variable. For that we have to find the minimum ratio. For finding minimum ratio, divide the constants by incoming variable column. This is your incoming variable column. So you have to divide the constant value with the incoming variable column. That is 4 divided by 4. This is equal to 1. The next one is 7 divided by 5. That is 1.4. The next one is 6 divided by 3. That is 2. From the values, you have to select the minimum one. Here the minimum value is 1. So you have to put an arrow mark like this. This represents the corresponding variable A1 leaves the table. So incoming variable is the x1, outgoing variable is A1. So the intersecting point is 4. So 4 is the key value. Now this is key row, this is key column. We want to find the optimum value. So we have to go to the next table. A1 leaves the table. So in the place of A1, here you write x1. For x1 the cost is minus 3. Then A2 no change, you write as it is, and S2 no change, you write as it is. Now we want to make pivotal element as 1. For that you have to divide by 4 throughout the row. Let me write 4 by 4 is 1. 4 divided by 4 is 1. 1 divided by 4 is 1 by 4. 0 divided by 4 is 0. 0 divided by 4 is 0. Artificial variable is leaves the table, so no need to write. You put a dash like this. Here 0 divided by 4 is 0. Now we want to make other element in the key column as 0. For that we have to use the formula new value is equal to old value minus key column value into key row value divided by key value. Now for the second row, old value is 7, key column value is 5, key row value is 4 and key value is 4. Like that you have to do for all the other values. Let me write. First old value is 7 minus key column value is 5, key row value is 4 divided by 4. Key column value and key value will not change for all the values. This is equal to 2. The next one is old value is 5 minus key column value and key value will not change 4, which is equal to 0. The next value is old value minus key column value divided by key value into key row value. So the value is 7 divided by 4. The next one is minus 1 minus old value is minus 1 minus key column value, key value into key row value. So the value is minus 1. The next one is 0 minus key column value, key row value divided by key value, that is 0. Now the last value is 1 minus key column value into key row value divided by 4. So the value is 1. So let me write the second row. The values are 2, 0, 7 by 4, minus 1, 0, artificial variable A1 is leave, so you put a dash like this, and 1. This we obtained from the new value formula. Now we have to apply the same formula for the third row. Old value is 6 minus key column value, key row value divided by 4, that is 3. Old value is 3, key column value, key value into key row value, that is 0. Next old value is 2, 2 minus 3 by 4 into 1. So the value is 5 by 4. The next value is 0 minus 3 by 4 into 0. So the value is 0. The next value is 1 minus 3 into 0 divided by 4. So the value is 1. Now the last value 0 minus key column value, key value into key row value is equal to 0. Third row values are 3, 0, 5 by 4, 0, 1, dash and 0. Now we have to find Zj value. Zj value in the usual manner, minus 3 into 1 plus minus 3 into 0 plus 0 into 0. The value is minus 3. The next one, minus 3 into 1 by 4 plus minus m into 7 by 4 plus 0 into 5 by 4. If you multiply and add, you will get minus 7m plus 3 by 4. The next one is minus 3 into 0 plus minus m into minus 1 plus 0 into 0. The value is m. The next one, minus 3 into 0 plus minus 3 into 0 plus 0 into 1. So the value is 0. This is artificial variable, so we'll leave it. And the next one, minus 3 into 0 plus minus m into 1 plus 0 into 0. The value is 0. Now we find Zj minus Cj. Cj is at the top, Zj is here. You have to subtract Zj minus Cj. That is, minus 3 minus of minus 3 is 0. Minus 7m plus 3 divided by 4 minus of minus 1. So you will get minus 7m plus 1 divided by 4. The next one, m minus 0, that is m. The next one, 0 minus 0, that is 0. The next one, you subtract this, you will get 0. Now we have to check Zj minus Cj values are positive or not. Here, one value is negative. So we have to go to the next table to get the best solution. Here, the most negative is this value. So the corresponding variable x2 enter into the next table. So this is key column. For finding the leaving variable, we have to find the minimum ratio, that is 1 divided by 1 by 4. This can be written as 1 into 4 by 1, that is 4. The next one, 2 divided by 7 by 4, that is 2 into 4 by 7. You have to write the reciprocal of that, 1.1. The next one is 3 divided by 5 by 4, that is 3 into 4 by 5, that is 12 by 5, that is 2.4. So the minimum value is 1.1. Put an arrow mark like this. This arrow mark represents the corresponding variable A2 leaves the table. So entering variable is x2, leaving variable is A2. The intersecting value is 7 by 4. So we can say that as a key value. This is key column and this is key row. For the third table, x1 is equal to minus 3 and A2 leaves the table. Instead of A2, here you write x2. x2 value is minus 1 and there is no change in S2. S2 is 0. Now we want to make pivotal element as 1, another element in the same column as 0. For making pivotal element as 1, you have to divide throughout the row by same element. That is 2 divided by 7 by 4 is 8 by 7. Then 0 divided by 7 by 4 is 0. 7 by 4 divided by 7 by 4 is 1. Minus 1 divided by 7 by 4 is minus 4 by 7. 0 divided by 7 by 4 is 0. Artificial variable, you put dash. Now, we want to make the other two values as 0. For that, you have to apply the formula. Let me write the values for the first row. Old value is 1. 1 minus 1 by 4 into 4 by 7 into 2. That is 5 by 7. The next value, old value is 1 minus 1 by 4, key column value. Key value is 7 by 4. That can be written as 4 by 7 into 0. So the value is 1. The next one is, old value is 1 by 4. 1 by 4 minus key column value into key value into key row value 7 by 4. If you simplify this, you will get 0. The next one, 0 minus 1 by 4 into 4 by 7 into minus 1. That is 1 by 7. The next value is 0 minus old value 1 by 4. Key value is 4 by 7 and key row value is 0. So the value is 0. Old value is 1. Key column value is 1 by 4, key row value is 2 and key value is 7 by 4. Similarly, you have to do for all the other values. Let me write the values. 5 by 7, 1, 0, 1 by 7, 0. Now we move on to the third row. For third row, old value is 3, key column value is 5 by 4, key row value is 2 and key value is 7 by 4. Like that you have to calculate for all the other values. Let me write. Old value is 3 minus key column value into key value into key row value, that is 11 by 7. The next value is 0 minus key column value into key row value, that is 0. The next one is old value minus key column value into key value into key row value, that is 0. The next one, 0 minus key column value into key value into key row value, that is 5 by 7. The next value is 1 minus, that is old value is 1 minus key column value into key value into key row value is 0. Simplifying this, you will get 1. The third row is 11 by 7, 0, 0 again, 5 by 7, 1. Artificial variables are leaves the table, so no need to find these values. Now we have to find Zj. Zj in the usual manner, minus 3 into 1 plus minus 1 into 0 plus 0 into 0. So let me write the value minus 3 and the next value is minus 1, then 1 by 7, then 0. You have to find Zj minus Cj. Zj is here, Cj is at the top. Okay, so you have to subtract these two values. Zj minus Cj is minus 3 minus of minus 3 is 0. Minus 1 minus of minus 1 is 0. 1 by 7 minus 0 is 1 by 7. Zj minus Cj is minus 3 minus of minus 3 is 0. Minus 1 minus of minus 1 is 0. 1 by 7 minus 0 is 1 by 7. 0 minus 0 is 0. So here all the values are positive. So the current solution is optimal. So you have to write all Zj minus Cj greater than or equal to 0. The current solution is optimal. The optimal solution taken from the table. x1 is equal to 5 by 7 and x2 is equal to 8 by 7. Therefore, max Z is equal to minus 3x1 minus x2 is equal to minus 3 into 5 by 7 minus 8 by 7. This is equal to minus 23 by 7. Your given problem is minimization problem. Therefore, minimize Z is nothing but minus of minus 23 by 7, that is 23 by 7. Optimal solutions are x1 is equal to 5 by 7 and x2 is equal to 8 by 7. Minimize Z is equal to 23 by 7. If you like this video, please share and subscribe. Thank you for watching.